Okay, so tonight we are talking about trigonometric identities. Yes, not the most exciting subject, but an important part of our general trig. This is not something that we've actually done together, so it's something that I wanted us to be able to spend a little bit of time talking about. No doubt your teachers would have been through this with you before, but just to go through some helpful, handy hints before you get started, please do take a screenshot of the tools you can use to prove identities, and you can use that later on. Okay, so the first thing to note is when you are proving an identity, you are not solving an equation. So because you are not solving an equation, you can't use the same methods as you would use when you solve equations. So for example, if you're solving an equation, you can do something to the one side, provided you do the same thing to the other side. Identities don't work like that. The idea is that you are starting with either the left or the right, and you are then working your way through the problem in order to obtain what was on the other side. So you can start with the right and simplify it and end up with what you had on the left, or you can start with the left and you can work through it until you get what is on the right-hand side. Okay, so you do not work with the left and the right-hand side simultaneously. You have to split them up, okay, which is the first important point. Okay, so we have to split the left-hand side and the right-hand side. We then need to use our identities. Okay, so the one identity that we must always use is our tan identity. So tan theta is sine theta over cos theta. We know this from grade 11 already. And the other identity from grade 11 is our square identity. So sine squared theta plus cos squared theta is equal to 1. So we mustn't forget about those. Often when we get stuck in matric, when it comes to identities, it's normally because we're not using a grade 11 identity rather than not using a grade 12 one. The other thing that we're obviously expected to do is to use our double and compound angle formulae where it would be appropriate to do so. And of course, you're going to expect that the identities in grade 12 will have double and compound angles in them. You're not just going to have identities which just contain the tan identity and the square identity. Another couple of important handy hints are the following. So trig often expects us to work with fractions. All right, so do not forget when you add and subtract fractions, you have to find a lowest common denominator. All right, so just like you would if you were adding simple number fractions, it would be the same idea with trigonometric fractions. And then the other thing that you must not forget about is factorizing. Okay, remember we cannot cancel over plus and minus signs. We can only cancel factors, we cannot cancel terms. So you need to be on the lookout for taking out a highest common factor, dots or difference of two squares, trinomials, and in some sort of rather extreme cases, grouping or sum and difference of two cubes. Okay, but certainly difference of two squares, highest common factor, trinomials are by far the most common. Of course, the other thing that we need are our formulae, which, where did I put them? Over there. Let me just go and grab those and bring them up here. So just a quick reminder. Sorry, that was me working on these a little bit earlier. There are our compound angle formulae. So those will be on your formula sheet, and of course our double angle formulae. Okay, so we're going to use these extensively as well as our tan identity and our square identity. So let's have a look at the very first example that they have given us. All right, so they want us to prove that 1 minus cos 2 theta over sine 2 theta equals tan theta. Okay, so in this case, there's a lot more going on in the left. We can see two double angles. On the right-hand side, we've only got tan theta. So essentially, when we simplify the left-hand side, what we want to end up with must be sine theta over cos theta. All right, or more than likely is going to be sine theta over cos theta. So setting it out, we would write left-hand side equals, although you don't specifically need to do that, and we would write down what the left-hand side is. So 1 minus cos 2 theta all over sine 2 theta. Now, when it comes to the cosine double angle, we have three options. So either we can write cos squared A minus sine squared A, or 2 cos squared A minus 1, or we can write 1 minus 2 sine squared A. If you can get rid of a 1, so here, if we can get rid of this 1 over here, choose an identity that is going to get rid of that 1. Which one would it be? So it's not going to be cos squared A minus sine squared A. So out of these two over here, 2 cos squared A minus 1 or 1 minus 2 sine squared A, which one would get rid of the 1 if we were to substitute? Any ideas? Remember, when I substitute, I'm going to use brackets. So what should I replace cos 2 theta with if I want to get rid of the 1 in front of the minus cos 2 theta? Any idea, Matrix? Gosh, shame these guys are really quiet tonight, aren't they? Shame you must be exhausted. Yes, Salma, I agree with you. I agree with you. 1 minus 2 sine squared A will get rid of the 1. So let's go and sub in. So we've got 1 minus 2 sine squared A. Lovely. And of course, when it comes to sine 2a or 2 theta, we've got no other, sorry, I shouldn't have written an a there, I should have written a theta. We've got nothing else that we can replace it with except 2 sine theta cos theta. So let's go ahead and do that. So 2 sine theta cos theta. Now, before I continue any further, it is very important to show your steps in trig. If you use an identity or a reduction formula, you need to show that. So as far as reduction formulae are concerned, you've got to show the result of the reduction formula. If you use an identity, so the tan identity, the square identity, or any of your double angle or compound angle formulae, you must show that that has been used. Okay, so first sub in. Then if you need to remove brackets, cancel things down, etc., go ahead and go and do that. All right, so now we've got 1 minus 1 plus 2 sine squared theta over 2 sine theta cos theta. At the top, the 1 minus 1, thanks Salma, that's going to cancel out. And that will leave us with 2 sine squared theta over 2 sine theta cos theta. Now, we have a monomial in the numerator. We have a monomial in the denominator. So we don't need to factorize. Okay, there are only factors here. All right, so we can cancel because we're not breaking any laws. 2 divided by 2 is 1. Sine squared theta divided by sine theta would be sine theta. So that means that we are left with sine theta in the numerator. And there we go. So we've got sine theta over cos theta. Let's write that first. And now we can conclude that it's equal to tan theta, and the right-hand side is equal to the left-hand side. Okay, are there any questions? How are we feeling? Is that all good? All good? Okay. All right. So this one was nice and easy to get our minds into the swing of things. Okay, cool. All right. So let's go down then. And have a look. Sorry, it's these questions over here. All right. So what I would like us to try now is we'll have a look at these ones a little bit later on, is we're going to have a look at A, B, and D. Okay. So before I do that other example that's up there, I would like a volunteer, whoever's the only identity you'll get today, Amahle. Okay, well then I promise to be gentle with you guys. So Amahle, I'm picking on you. Choose. Are we doing A or B or D? Which one would you like to try? A, B, or D?
Let's go with A.
We're going to go with A. Okay, all
Yes,
right. So I
please.
tell you, all right, that's fine. Amahle, you happy to do this one for us?
Can I have time to quickly do it on paper?
That's fine. Okay, so Amahle
Okay, thank
says
you.
no problem, Amahle. Okay, so Amahle says that we are looking at identity A. So give that a try, guys, and let's see what you come up with. So I've got the formulae on the screen here. I hope everybody can see what's going on. So we're trying identity A, and when you think you're done, then you can just say done in the chat.
Okay, I don't want to be in a video.
Well done, Ntokozo. Nhlanhla's also done. Cool. Gadi's done. Daka's done. Mamelo's done. All right, good stuff. Mtlebo's done. Salma's done. Lebogang is done. All right, so a lot of you are already finished. Okay, so there is the left-hand side on the board. Can anybody tell me what the next line was that you got? So after you wrote down the question, essentially, what did you have in your next line of working? Anybody willing to share with me what you did? Sandiswa? Okay, Ntokozo, you got a hand up? Okay, go for it, Ntokozo.
Hi, ma'am.
Hi, Ntokozo.
I got cos squared theta
Mm-hmm.
plus 2 sine theta cos theta
Mm-hmm.
plus sine squared theta.
Excellent. Well done. What did you do after that?
Okay, I put I said sine squared theta plus cos squared theta plus 2.
I want to start over here.
And then sine squared
Cool.
theta plus cos theta is equals to 1. I use the identity.
Lovely.
Yes, plus 2 sine theta. Plus and then 2 sine theta cos theta is also the sine 2 theta identity.
It certainly is. Well done. That was beautifully explained. Good. Good. Maybe that one was a little bit too easy for you guys. Should we try something that's a little bit more difficult?
Yes, please. Yes,
Oh,
ma'am.
okay. All right. Tell you what, let's try D. Let's try D. And then we're going to go to something a little bit more difficult than this. Okay, good. I'm glad that was at least a nice warm-up for your brains. Let's try question D. And then we can go, well, D will be a little bit more difficult. And then we can go something harder than that. So you guys try this. And then again, when you're done, you can say done in the chat.
Ma'am, I got cos 2x, then sine x minus cos x
For which one?
for the number D, ma'am.
For D. When you say, what did you say you got? Sorry, to say that again, please.
I got cos 2x at the top.
Okay, the
And
numerator.
then the numerator. And then at the denominator, I got sine x minus cos x.
Okay, so how did you get cos 2x in the numerator?
I used the identity.
Okay, so which identity did you use? Because you've just got to be careful here, because cos 2x is not equal to 1 minus sine 2x. It's got to be 1 minus 2 sine squared x.
1 minus 2 sine squared x.
Ah, absolutely. So there's
Oh,
not a square on here, so that's why you can't rewrite the numerator as cos 2x. Does that make sense to you?
well, could you please re-clarify it, ma'am?
Sure, no problem. Okay, everybody else continue, unless, of course, you want to listen. In the numerator, you've got 1 minus sine 2x. The identity is 1 minus 2 sine squared x. So you can see here, this is not the same as this, is it?
Yes, ma'am.
Okay,
There's
so
a
there's a square and there should be a 2 in the front.
square.
So the one at the top is equal to cos 2x. The one at the bottom isn't.
Yes, ma'am.
Okay, so that means you need to think about something else. So you've got your sine double angle. So expand that to 2 sine x cos x. So in your numerator, you should actually have 1 minus 2 sine x cos x.
Oh,
Okay.
close
So
enough.
completely different to what you thought.
Yes, ma'am.
Okay. Yolanda, I haven't been looking at the chat. Are there people that have said that they're done already?
Yes, many
No.
of them are done.
Okay, all right.
Oh, yeah.
Remember
I
to
see.
mute. Remember to mute yourself. Yeah, but many
All
are
right.
done, Shelley, so we are good to go.
Okay. Are we good to go? Okay. All right. So if you didn't manage to finish all of this, it's not the end of the world. This is what we should have done in this case. We would have written 1 minus 2 sine x cos x. And then at the bottom, we would have kept that as sine x minus cos x. So we have 2 terms at the top, 2 terms at the bottom. You cannot cancel terms. Okay, you can only cancel when you factorize. So we can't factorize here, so there's got to be something else that we can do. All right, so can somebody tell me, what did you do in the numerator? All of those people that are done, what did you do in the numerator to help us on to the next step? Any suggestions? What can I do in the numerator to take me on to the next thing? Leanne, go for it.
Hi,
Leanne.
ma'am.
Hi, Leanne. How are you?
I think that we should change the.
Hi, Leanne. How are you?
I'm
Sorry,
getting you.
I'm fine, thank you. Sorry, it's echoing. Go for it. Sorry, I'm fine, thank you. Sorry, it's echoing. Go for it.
Ma'am, I think that we should change the 2 sine x cos x from a double angle.
Okay, so I've done that. I've taken sine 2x and I've written it as 2 sine x cos x.
So I've done
What can I do with a 1?
I've taken sine 2x and I've written it as 2 sine x cos x. What can I do with a 1?
Miss, we can change it from 1 to sine plus cos x.
Okay, so sine squared x plus cos squared x.
Sorry, Leanne, because you are echoing. So what we would work for us is whenever you want to talk, you just unmute yourself, you say whatever you say, and then you mute yourself and you let teacher Lee talk, okay? So you are doing really well. Sorry, I'm just trying to get rid of the echoing, okay?
Thank you, Yolanda. All right, so I'm going to do this. And at the bottom, I'm going to write my sine x minus cos x. All right. Why have I written what I've written in the numerator? What I've written over here, am I allowed to do that? Is that okay for me to do this? Any questions about what I've done here, or does that make sense to everyone? Yes. Okay, Nhlanhla says yes. Good stuff, Nhlanhla. Okay, another thumbs up. All right, lovely. And you notice I put the sine squared x at the front because I've got sine x at the front over here as well. Yes, because I'm creating a quadratic. Beautiful. Okay, so then that means I'm now going to factorize. So I'm going to have sine x minus cos x in the one bracket. And I'm going to have sine x minus cos x in the other bracket as well. And at the bottom, I've got sine x minus cos x. Okay, and now that I have factorized, now and only now, can I cancel something at the top? Whoopsie daisy, with something at the bottom. Let me just go back here, and there we go. We've got the sine x minus cos x equal to our right-hand side that we wanted. Okay. All right. Okay, so Salma's okay. Mamelo, you didn't understand that step. Lebogang, no problem. Okay, so there's a couple of people that I lost here. Not a problem. So let me just explain to you very quickly what I have done. Okay, remember, if I have 1 and I've got minus 2 sine x cos x. So I'm just talking about the numerator now. I am taking 1 and I'm rewriting it as sine squared x plus cos squared x. And then I'm going to bring down my minus 2 sine x cos x. And then all I did was a little switch around. So in other words, I kept the sine squared x as the first term. I moved minus 2 sine x cos x into the middle, and I put the plus cos squared x at the end. Okay, so I'm allowed to rearrange my terms. All right, so that's what I did in order to end up with this. And the reason that I'm doing it, like I think Amahle said, is because I'm trying to create a trinomial that I can factorize. Does that make sense now? Okay, Lebogang, good, Mamelo. All right, so that's what I was doing. Okay, but I don't have to show all the steps in black. I can go straight from the second line to the third line, and I'm not going to lose any marks. Okay, you're allowed to do that. So hopefully that makes a little bit more sense to everybody. Okay, so now that we are feeling a little bit more warmed up, shall we go on to something that is a bit more difficult? Don't forget to take screenshots. And let's go and have a look at something else that's a bit harder. Yes, okay, lovely. All right, so I would like us to have a look, first of all, at question number 5. And the reason I want us to look at question number 5 specifically is because it's just put that over there. All right, so question 5. That's this one over here. We've got sine theta plus sine 2 theta over 1 plus cos theta plus cos 2 theta, and we've got to show that that's equal to tan theta. All right, so we'll start in our normal way with our left-hand side, and our left-hand side is equal to sine theta plus. What am I going to do with sine 2 theta? How would I rewrite that? So either in the chat or if you want to unmute. What am I going to do with sine 2 theta? Into Kozo? Hi.
Don't we, because the sine 2 theta is an identity,
Mm-hmm. Mm-hmm.
we must make it 2 sine theta times cos theta.
Beautiful. Okay, now, while I've got you into Kozo, I want you to have a look at the denominator for me. I can't change, well, I'm not going to change the 1 for now. I'm going to leave the cos theta as it is. What am I going to do with cos 2 theta? How do you know what to change cos 2 theta into? Do you have any idea into causal?
Ma'am, you
Yes,
can use the
Andisiwe.
icon.
What can I
Tell her,
rewrite it as?
you may rewrite it as 2 squared cos theta, ma'am.
Okay, so I'm using this
This,
cosine double
yes,
angle over here. Okay,
yes, ma'am.
so all right, so you will know, thank you, Sandisiwe, that's lovely. All right, so you know how to rewrite your cosine double angle depending on the other terms that it appears with. So if cos 2 theta appears with cos theta, all right, then write cos 2 theta as 2 cos squared theta minus 1. If cos 2 theta appears with sine theta, then write cos 2 theta with 1 minus 2 sine squared theta. Okay, so we're going to go with 2 cos squared theta minus 1. Okay, it's also going to cancel out the 1. So that gives us sine theta plus 2 sine theta cos theta all over cos theta plus 2 cos squared theta. Now remember, I cannot cancel over plus and minus signs. All right, so I have to factorize. Okay, so I'm going to move that out the way now. All right, what sort of factorizing am I doing in the numerator, Matrix? Is it a trinomial? Is it difference of 2 squares? What am I doing? Common factor, yes. Sisipo, okay, good. Amahle, remove the common factor. What's the
Yes,
common
ma'am.
factor?
2
Sine theta, good, and
sine
quite
theta.
right. Sine theta, good. So I'm going to take out sine theta. In brackets, I'm going to be left with, whoopsie daisy.
And anyone who wants to talk, it will be nice to raise your hand. Do you know how to raise your hand? There's a reaction button there. When you press the reaction button, just raise of a hand so we can see who's talking, because we're going to be talking over each other. And sometimes I just feel like it's noise and you're not answering the question. So I accidentally mute you. Sorry. So raise your
Okay,
hand.
there we go. Cool. Thank you, Yolanda. All right, so we're going to take out a highest common factor. So now you can see the factorizing coming into play. We're going to factorize the numerator by taking out sine theta, factorize the denominator by taking out cos theta. And now that we have factorized, again, we can cancel something at the top with something at the bottom. We end up with sine theta over cos theta. And we know that that is equal to tan theta. Okay, and it equals the right-hand side. Okay, so now that we've had a look at one that has some factorizing in it, I am going to challenge you guys to a slightly more difficult question. Okay, so this is what I'm going to do. Hang on 1 second. Okay, so now things are starting to get a little bit more difficult, all right, which is what I wanted to do, but hopefully not make it ridiculous. Okay, I'm going to give you guys that one. Okay, so I'd like you to try this question. It's actually question number 7. I've just snipped it out and stuck it here. You guys are going to try this one. Question 7, please, matrix.
Ma'am,
Mm.
I got cos theta over sine theta to change the tan theta first, plus the cos theta and sine theta.
That's correct. So you're right with the tan theta. Okay, so now you're going to see where, okay, that's a good first step. See where you go from there.
Okay.
Yes, Amahle, I can. Sorry. Sorry, guys. Just stick it over there. Whoopsie.
Oh.
All right.
Okay, Sandisiwe, you keep on unmuting yourself, girl. I've been trying to mute you and mute you. You just keep on unmuting. So
Sorry,
I'm not sure
ma'am.
why can't you stay muted, Mughal? Oh, raise your hand. There's a button there that says reaction. You click on it and then you can raise your hand and don't mute yourself until Teacher Lee says, Sandisiwe, you can give us an answer. Okay. That's how it works, girl. Let's do
Yes,
this.
ma'am.
Let's do this the right way. Yes. Yes. I'm glad you understand. Yes, well done, Sandisiwe. So you stay like that because Teacher Lee is waiting for other learners to be able to work out the example that she's giving there. Then when she's ready, she will say, oh, Sandisiwe has an answer for us. Let's go. But you stay like that, okay? We hope you have written this on your book also. Okay. So let's just wait for the rest of the class to say done, which you will normally check on your chart. And then Teacher Lee will give a go ahead on what we need to do, okay? So just raise your hand, let it stay there for now.
And of course, when you guys are done, then you can say done in the chat and we can look at the answers. Well done, Sandisiwe. Sandisiwe, if you are done, I'm going to go and grab another question, which I'm hoping we will have time to talk about. The rest of you just continue working.
So Ma'am,
Hello. Who's that?
that's Sandisiwe, ma'am.
Yes, hello,
For the
Sandisiwe.
In order to get the 2 at the top, ma'am, I cancelled the cos theta and cos theta, and then there's a 1 as a coefficient over there. So 1 plus 1 would make the 2. Am I correct, ma'am?
So
What?
sorry. Sorry,
Sorry,
Teacher Lee, it's
Yolanda.
because I don't want them to be confused. So Sandisiwe, we know that you've already done, but Teacher Lee has put another question for you because the rest of the class, they are still working on that example that you had done. So you're working like a speed of light, which is great, but we need to wait for the rest of the class because otherwise then they're just gonna listen to what you are saying as an answer without trying, okay? So let's give them time to try. While you're finished with that one, please feel free to continue number 8. Try that question. And then when you're done, you can say done, and we're going to keep on giving you more examples for you to do, okay? Because the class is working a little bit slower than you are. Okay, so you can just mute for now. Don't forget, Matrix, to say done for the first one, okay, for number 7, so that we can go over it. You don't have to do 8. Just when you are done with 7, just say done, like this, Teacher Lee. Yes, Kopano, thank you.
There we go. Perfect.
Yeah, so we can be aware. Yes, Lebohang, thank you. Thank you, Nomtebo. Thank you, Tamia. Okay, we're getting there.
We are indeed.
Thank you, Dagalo. Nice. Uratile. Okay.
All
The
right.
huge majority of us should be done with number 7.
Should be done
Well
by
done,
now.
guys.
Okay,
Yeah.
lovely. All right, very good. Okay, so we're going to try and do this a bit together, and a little bit I'll do and a little bit you guys will do. All right, so hopefully everybody wrote tan A as sine A over cos A. So remember, if we've got an identity, we've got to show that we've used it. All right, so I've done the first step. What is the next step? So cool, Amahle. So what is the next step? After writing tan A as sine A over cos A, what's the next thing that we should do? What did you do, Matrix? Anybody willing to share? That's it, Amahle. Why, quite right. Okay, so there's a couple of people with hands up. Oh, okay. Finding a lowest common denominator. So we would find our lowest common denominator by multiplying cos A and sine A together, right? So that would give us an LCD of sine A cos A. That's it. Okay. So at the top, the first term is going to be sine squared A, and the second term is going to be cos squared A. Are we all good up to this point? Did we all have the same thing? Okay, excellent, Sisipo. Okay, and now we know that sine squared A plus cos squared A is 1, like Sandisiwe was telling us, and we have now got sine A cos A at the bottom. Yes, lovely. All right, and now, Sandisiwe, to answer your question, and everybody else, in case you were wondering what to do when you got to this step, you are allowed to multiply this by 2 over 2. The reason that you're allowed to multiply it by 2 over 2 is because 2 over 2 is 1. Okay, so you can multiply the top by 2 and the bottom by 2. When we multiply fractions, we multiply numerator with numerator and denominator with denominator. So that gives us 2 sine A cos A, and eventually this gives us 2 over sine 2a, and it's equal to the right-hand side. Okay, so Sipho, I see your hands up.
Ma'am.
Hi.
Hello. I wanted to ask if is multiplying by 2 over 2 like the better option than just going to the right-hand side and changing that identity and then canceling out?
No problem with that at all.
Oh,
so if you
okay,
want to
thank you,
go,
ma'am.
if you want to go to the right-hand side and go and work with that identity, you can. With this one, you'd get as far as 1 over sine A cos A, and you wouldn't be able to go any further, so you'd go to the right-hand side. As long as you work with the right and the left separately, it's not a problem. Okay, this
Oh,
might be
okay.
a little bit faster, and that's all. Okay, but nothing wrong with what you did. Okay. Amatle is asking me to do that. Fine, Amatle, that's not a problem. Okay, so if you worked with the right-hand side, Amatle, you would have 2 over sine 2a. So that would give you 2 over 2 sine A cos A. And then you've got one term at the top and one term at the bottom. So you can say 2 divided by 2 is 1. And then you'd have 1 over sine A cos A. All right, so in other words, what you are now leaving out, Amatle, is this bit where I multiplied both by 2. Okay, so you've worked with the right and the left, and then you can conclude here, okay, therefore left-hand side equals right-hand side, and that's just fine as well. Okay. All right, no problem. Linda, the cos A didn't go anywhere. We used the identity. And Nhlanhla, the second step, when you say the second step, Nhlanhla, do you mean this one over here? The one where I've put a pink arrow? That's fine, Amahle, not a problem. Pretty, you think up the 2 over 2. Okay, so you're allowed. So if I take a fraction, let's say I've got a fraction that's 1 over 7. I'm allowed to multiply it by 1. So I can say that 1 over 7, let's say, is equal to 2 over 14. Those are still equal to each other. All right, so where you would have seen something like this is, remember when you learned how to rationalize the denominator. So let's say you've got something like this, 1 over root 2. You're allowed to multiply that by root 2 over root 2, aren't you? Okay, so you're still multiplying it by 1. So there you would rationalize the denominator, for example, and end up with root 2 over 2. It's the same idea. Okay. Third, yes. Okay. So in Nhlanhla, what we did here is we made the lowest common denominator the same. All right. So in other words, or had a lowest common denominator. So here I would have multiplied, let's use a different color. So here I would have multiplied this by sine A. What I do to the bottom, I must do to the top. And then on this side, I would have times that by cos A. So what I do to the bottom, I do to the top. And that's how I would have ended up with sine squared A plus cos squared A over sine A cos A. Does that make sense? Nombuso, you are allowed to multiply a fraction by 1. So if I have a fraction 1 over sine A cos A, I'm allowed to multiply it by 2 over 2. Because I'm still multiplying it by 1. I'm not changing its value. Okay, so you are allowed to do that. In fact, there are some places in trig where you absolutely have to do that. Okay, so that's but I'll show you something like that later on. Got it. Okay, cool beans. Right. Okay, so we've got just under 10 minutes left. Leanne, ma'am, please explain the part where we multiply with 2 over 2. Okay, so Leanne, just to go through that again, if you have got a fraction and you multiply it by 1, which is what 2 over 2 is, you're not changing the value of that fraction. So you're allowed to do that. Okay, so if I wanted 2 over sine 2a, I know that if I multiply the top by 2 and the bottom by 2, I can get the 2 at the top, and I can make my sine double angle identity at the bottom. Okay, so I'm not changing the value of 1 over sine A cos A if I multiply it by 2 over 2, because 2 over 2 is 1. Right. If you don't like that, or you don't think that you'd want to use it, that's fine. Then you can do what Amahle did, all right, and rather work with the right-hand side. Okay, the choice is yours. No, you're not cross-multiplying, Nombuso. Because remember, when you multiply fractions, you multiply numerator with numerator and denominator with denominator. So when you are cross-multiplying, okay, that's when you are solving a fraction, solving an equation. Okay, so you cross-multiply to solve an equation. So for example, if you have something like 3x over 7 equals 2 over 9, then you can cross-multiply. Okay, that's to solve an equation. Here, you're not cross-multiplying. You're multiplying numerator with numerator, denominator with denominator, because that's how you multiply fractions. No problem. Okay.
Can I run the poll, or do you
You
still
may
want
run the poll. No, you may run the poll. That's not a
Thank
problem.
you. Let's do the poll, my people. Nice, guys.
So please do answer the poll.
Yes, please. You guys did well today.
You did, especially considering how tired you all are.
Yeah. That none wanted to talk to us.
Oh, shame.
At the beginning.
Yes,
Oh.
Capano, we can. All right, we can do number 8 on Monday when I see you guys again. So I'm just going to scroll up there. Have a look at question 8, and then we'll start next lesson doing question 8.
Only 3% of us. Oh, now we are done. Just need to take my screen.
Amahle, it's like everything. It's just practice, practice, practice.